Hello, and welcome to the Mac mini-series on ordinary differential equations. My name is Jeremiah Ayers, and I'll be helping you get acquainted with ordinary differential equations, also known as ODEs. Your goal for this video is to learn more about how to recognize ODEs. This video is one of many resources available for your learning benefit. If you want more, or if you want to test your knowledge of what you've learned so far, we have also included worksheets to enable your further study. You can also use the included solutions to help further refine your knowledge. So, what is an ODE? Well, an ODE is just one member of a much larger family of equations. This is the family of differential equations, which we'll talk about first. A differential equation is simply an equation involving derivatives. For example, this is a differential equation since it has a derivative. Here is another example. This is also a differential equation since it has a derivative. ODEs, as you can see, can include many levels of complexity based on what you are modeling. Try your hand at this one. Is it a differential equation? The answer is this is not a differential equation because it contains no derivatives. When studying ODEs, we are interested in not just any differential equation. We will be looking at a more specific type of differential equation, the ordinary differential equation. So, what does it mean for a differential equation to be ordinary? Well, a differential equation involves derivatives. So whatever defines an ordinary differential equation must have something to do with the types of derivatives involved. Let's look at a few examples first. Consider this differential equation. Note that the derivative is dy over dt, which uses your typical looking letter d. This indicates that the only way for y to change is if t changes. In other words, y does not depend on any other variables. Because of this, y can depend on only one variable, and therefore we say that the derivative is ordinary. And since this is a differential equation involving only ordinary derivatives, it is an ordinary differential equation. Now, look at this example. Is it an ODE? If you're not sure, take a look at the derivative term. This is a little different from the previous example since we don't have any d's involved anymore. Instead, we have prime used for the derivative. But remember, prime means that we are taking a derivative with respect to a single variable only. So in this example, we have used a prime indicating a derivative with respect to only a single variable. So, as in the previous example, this too is an ODE. Now, consider this example. Is it an ODE? Note that this equation involves partial derivatives. Remember that if you take the partial derivative of z, you're assuming z is a function of not just one variable, but at least two variables. So, unlike the previous case, z depends on more than one variable, and therefore this differential equation cannot be an ODE. So, in general, first, always remember that a partial derivative is not ordinary. But derivatives with d's, primes, or even dots are with respect to a single variable and thus are ordinary. And second, remember that any differential equation which involves only ordinary derivatives is considered an ordinary differential equation. This concludes the Mac Mini on identifying ordinary differential equations. I highly recommend checking out the worksheets to reinforce what you've learned while watching this video. When you're ready, feel free to watch the next video, in which I'll answer the question, what does the answer to an ODE look like? Bye!